Okay, this video is about Dalton's law of partial pressure and mole fractions. So, Dalton's law of partial pressure says the total pressure in a container is equal to the sum of the partial pressures of all the gases in there. And then that's also related to what's called a mole fraction. So this x variable is the mole fraction. So the partial pressure of a gas is equal to the mole fraction of that gas times the total pressure present. So let's do some math problems. So we have a flask. It has 3 gases, so that means there are 3 partial pressures. The first one is 5 kilopascals of hydrogen. And then the second one seemed to have gotten cut off, so this is of hydrogen. The second one is 4.56 kilopascals of oxygen. And then the last one is 0.52 kilopascals of argon. So if I have 3 partial pressures, 1, 2, 3, and I want the total pressure in the flask, P total, I'm going to need the partial pressure of hydrogen plus the partial pressure of oxygen plus the partial pressure of argon, and just add them up. So 5 plus 4.56 plus 0.52, which gives me a total pressure of 10.08 kilopascals is my P total. Alright, so that's Dalton's law of partial pressure. Let's look at the second part of the problem. It says calculate the mole fraction of H2. Well, this is the equation for mole fraction. So the partial pressure of hydrogen is equal to the mole fraction of hydrogen times the total pressure. We were given in the last problem the partial pressure of hydrogen right here. And we also solved for the total pressure in the last problem, so we can find our mole fraction. Mole fraction is going to be equal to partial pressure divided by total pressure. And that's just rearranging the equation to solve for mole fraction. So it is 5 kilopascals divided by 10.08 kilopascals to get a mole fraction of 0.496. And that is Dalton's law of partial pressure.